Hi everyone, welcome back to my YouTube channel. Today we are going to discuss about classical encryption techniques from the subject cryptography, and the subject code is 18CS744. The contents are cryptography, substitution techniques. Under substitution technique we have Caesar cipher, Playfair cipher and Hill cipher. First we look into what is cryptography. The word cryptography was derived from combining two Greek words crypto, that means hidden, and graphen, meaning writing. So cryptography, it is the art of secret information writing or secret data writing. The main goal of the cryptography is a data secure from unauthorized persons or attackers or hackers. Cryptography is a method of storing and transmitting data in a particular form so that only those from whom it is intended can read and process it. The cryptography flow is shown here, where the plain text is sent for the encryption process, and then obtain the cipher text. From cipher text we'll process it to the decryption, and then we will get again the plain text. This process is done with the help of the secret key. The secret key is sent to the encryption, where you'll get the encrypted text to the cipher text, then also the secret key to the decryption again to get back to the plain text. Classical encryption techniques. They are basically two building blocks of encryption techniques. One is a substitution, next is a transposition. In this, we are seeing only the substitution. And what are the substitution techniques? A substitution technique is one in which the letters of the plain text are replaced by the other letters or by the numbers or symbols. If the plain text is viewed as a sequence of bytes, then substitution involves replacing the plain text bit pattern with a ciphertext bit pattern. The first one is a Caesar cipher, the earliest known use of the substitution cipher, and the simplest was by Julius cipher. The Caesar cipher involves replacing each letter of alphabets with a letter standing three places further down the alphabets. So now let us look into one example. So here it is a plain text, that is, meet me after the Togo party. The cipher text, how this cipher text comes is that we will see in the next slide. The plain text is like A to Z, and the ciphertext. Ciphertext is like last XYZ will have the starting alphabet, that is ABC, and starting of the ABC will continue with the D. Then here one more rule is that A should start with the numbering 0, so that Z will end with the number 25. So now let us look into the example, meet me after the Togo party, where the plain text it is that, where the cipher text M, it is cipher is P. How it is, where M has the corresponding cipher as P. Similarly E as the corresponding cipher H. Then T has the corresponding cipher W. So similarly, you have to write the cipher for the whole plain text. Now moving on, see the from the cipher text P. P is starting with the numbering 15. So from the 15, you have to start the writing of the alphabets A, B, C, D, E, and so on till 1. That is the last letter till 1 you will get it for O. Then coming to H. H has the number 7. So from the 7 you have to write it in the next row. That is A, B, C, D, E, F, G. Then similarly for one more E. Then coming to T. T has the numbering 22. So where you will have to write 22, then you have to start writing from 22 to 1 alphabets. So at the final you'll have to get the complete plain text in the third row. So meet me after the Togo party. So this is how the Caesar cipher works. Moving on to Playfair Cipher. The best known multiple letter encryption cipher is a Playfair Cipher, which treats diagram in a plain text as a single unit and translates these units into cipher text diagrams. The Playfair Cipher algorithm is based on the 5x5 matrix that is constructed using a keyword. In this example, we will look into the 5x5 matrix which has the keyword monad. These are some rules that are to be followed when applying the Playfair cipher. First, you have to write the diagram, then repeating letters, that is a filler letter, then same column you have to wrap around, same row again you have to wrap, then if it forms a triangle, you have to swap it. Now let us look into some example where the plain text is meet me after the schoolhouse. Now, the first rule is that we have to split the each letter to two letters from the plain text where it comes like ME, ET, ME, AT, TH, ES, CH. Now here you'll have encounter the double O where that is a repeating letter. So you have to add X after O and so that you'll have OX, then OL, OX. Here you'll add the X. So OX, OL, H, HO, US. Then here only E is left out at the last. So you have to add EEX to the filler letter. That is combining you'll have EX. Then how to write the corresponding cipher? First, that is M and E. You have to check in the matrix where does M and E lies. M and E that lies in the same column. So you have to wrap around. So for M it will comes to C. For E it will for M you can write it as C. For E you can write it as L. So ME is done. Then coming to ET. Where does ET lies? E here in the diagram in this 5x5 matrix. Then T lies here where which forms the rectangle. So after forming the rectangle, you have to swap. So for E, you'll have the corresponding swapping letter as K. For T, you'll have it as L. Then similarly, ME, already you have seen that for M it is C, for E it is L, that is the same column. Then so on. If you completely complete the two splitting of two alphabets and the corresponding cipher from the 5x5 matrix. Next one, that is a Hill cipher. Hill cipher developed by mathematician Leston Hill in 1926. The encryption algorithm takes m successive plain text letters and substitutes from their m cipher text letters. The substitution is determined by m linear equation in which each character is assigned a numeric value from a is equals to 0 till z is equals to 25. So you can express in the terms of column vector and matrices C1, C2 and C3 that has the K11, K12 and K13 with the corresponding P1. Similarly, K21 second row and third row with a mod 26. So this how you can write it is that C1. C1 you can write in the way like K11 K11 into P1 plus K12 into P2 K13 into P3 into mod 36. That comes the C1. Similarly for C2 and C3. Now we will look into some example. So example, we have to encrypt the message act where n is equal to 3. The given key for the act is GYBNQKURP, which in the form of a n cross n matrix looks like this. So for G, the value is 6. How it is like A that is to be started from A should be equal to 0 till, so that the G value will be 6, and so on till if A is equals to 0, the Z will have the value as 25. So for Y it is 24, for B it is 1, and similarly so on. You have to complete the 5 cross 5 matrix for the given key. Then coming to act. For A it is 0, for C it is 2, and for 19 the alphabet is T. So that is a act is given in the form of the 0 to 19, the vector. So here the resultant n-cipher vector will be from the formula C1 is equals to K11 P1 plus K12 P2 plus K13 P3. So you'll have 6 into 0 plus 24 into 2 plus 1 into 19. So that gives the value 67. So when you take the mod of the 67 with a 26, you'll get 15. Similarly, 13 into 0, 16 into 2, and 10 into 19. That gives the value as 222. The mod of with it is 14. Then similarly, the next one. So you have to consider the mod 26. So the resultant in the cipher text of act is POH.